Parsons 20th edition, Part 10, Disorders of the GI System. This is Section 1, Disorders of the Alimentary Tract, Chapter 314, Approach of the Patient with GI Disease. This is page 2177. Anatomic considerations. The GI tract extends from the mouth to the anus and is composed of several organs with distinct functions. Specialized sphincters that assist in gut compartmentalization separate the organs. The gut wall is organized into distinct layers that contribute to regional activities. The mucosa is a barrier to luminal contents or as a site for fluid and nutrient transfer. Gut smooth muscle in association with the enteric nervous system mediates propulsion from one region to the next. Many GI organs possess a serosal layer that provides a supportive foundation and permits external input. Interactions with other systems serve the needs of the gut and the body. Pancreaticobiliary conduits deliver bile and enzymes into the duodenum. The vascular supply is modulated by GI activity. Lymphatic channels assist in gut immune activities. Intrinsic nerves provide the controls for propulsion and fluid regulation. Extrinsic neural input provides volitional or involuntary control that is specific for each gut region. Okay, so that is the anatomy. Let's go to functions of the GI tract. The GI tract serves two main functions: assimilating nutrients and eliminating waste. In the mouth, food is processed, mixed with salivary amylase, and delivered to the gut lumen. The esophagus propels the bolus into the stomach. The lower esophageal sphincter prevents oral reflux of gastric contents. The squamous esophageal mucosa protects against significant diffusion or absorption. Aboral esophageal contractions coordinate with the relaxation of the upper and lower esophageal sphincters on swallowing. The stomach triturates and mixes the food bolus with pepsin and acid. Gastric acid also sterilizes the upper gut. The proximal stomach serves a storage function by relaxing to accommodate the meal. Phasic contractions in the distal stomach propel food residue against the pylorus, where it is ground and thrust proximally for further mixing before it is emptied into the duodenum. The stomach secretes intrinsic factor for vitamin B12 absorption. Most nutrient absorption occurs in the small intestine. The intestinal mucosal villus architecture provides maximal surface area for absorption and is endowed with specialized enzymes and transporters. Triturated food from the stomach mixes with pancreatic juice and bile in the duodenum. Pancreatic juice contains enzymes for carbohydrate, protein, and fat digestion, as well as bicarbonate to optimize the pH for enzyme activation. Bile secreted by the liver and stored in the GV is essential for lipid digestion. The proximal intestine is optimized for rapid absorption of most nutrients and minerals, whereas the ileum is better suited for absorbing vitamin B12 and bile acids. Bile contains byproducts of erythrocyte degradation, toxins, medications, and cholesterol for fecal evacuation. Small intestinal motor function delivers indigestible residue into the colon for processing. The ileocecal junction is a sphincteric structure that prevents coloileal reflux, maintaining small intestinal sterility. The colon prepares waste for evacuation. The colonic mucosa dehydrates the stool, decreasing daily volumes of 1,000 to 1,500 ml in the ileum to 100 to 200 ml expelled from the rectum. The colon possesses a dense bacterial colonization that ferments undigested carbohydrates and short-chain fatty acids. Additional roles for the gut microbiome include modulation of immune and physiologic activity. Transit in the esophagus takes seconds and times in the stomach, and small intestine range from minutes to few hours. Colon propagation requires more than 1 day in most individuals. Colon contractions exhibit to and fro character that promotes fecal desiccation. The proximal colon mixes and absorbs fluid, while the distal colon exhibits peristaltic contractions and mass movements to expel the stool. The colon terminates in the anus, which possesses volitional and involuntary controls to permit fecal retention until it can be released in a convenient setting. Let's go to extrinsic modulation of gut function. GI function is modified by influences outside the gut. Protective mechanisms are vigilant against damage from foods, medications, toxins, and infectious organisms. Mucosal immune mechanisms include epithelial and lamina propria, lymphocyte and plasma cell population supported by lymph node chains to prevent noxious agents from entering the circulation. Antimicrobial peptides secreted by intestinal Paneth cells also defend against luminal pathogens. All drugs and toxins absorbed into the bloodstream are filtered and detoxified in the liver via the portal venous circulation. Although intrinsic nerves control most basic gut activities, extrinsic neural input modulates many functions. Many GI reflexes involve extrinsic vagus or splanchnic nerve pathways. The brain-gut axis alters function in regions not under volitional regulation. As an example, stress has potent effects on gut, motor, secretory, and sensory functions.